Imagine this, you, floating alone in the universe. Out there is a spiral galaxy, majestic, almost infinite, and somewhere, almost invisible, is our tiny Earth. That's us, one speck, lost in the cosmic dark. And as awe-inspiring as that is, it's also, well, a little disappointing. Because as far as we know, the distances between worlds aren't just big, they're overwhelming. Let's say you built the fastest spaceship ever. Even then, the Andromeda Galaxy, our closest galactic neighbor, would still be a faint dot. The universe is measured in light years, the distance light travels in a year. And light, the fastest thing we know, still takes over 2 million years to reach Andromeda. That's how empty and vast things really are. So, is there any hope for us as individuals? Could there actually be a shortcut? A way to leap across the void? Right now, it looks like a galactic impasse. But let's get a little abstract. Picture space-time as a dark, rippling ocean with glowing islands, galaxies, scattered far apart. What if somehow the space between them could be folded? Enter the concept of the wormhole. Not just science fiction, but a real idea rooted in physics. Imagine a sphere of light warping the stars behind it, almost like a cosmic gateway. That's what a wormhole could look like. This isn't just fantasy. It's based on real science, thanks in part to Einstein. He showed us that mass and energy can curve space-time itself. Think of it like a trampoline. Put a heavy ball in the center, and the fabric dips. That dip is gravity. Now, check this out. Here's Einstein's field equation. Don't worry, you don't need to solve it. Just know that it describes how matter tells space how to curve, and space tells matter how to move. When enough matter is packed tightly, it can bend the cosmic fabric so much that it pinches off completely. That's a black hole, a spot where the rules of the universe go wild. But, and this is wild, those same equations allow for another possibility. Instead of a pinched-off void, you can get a tunnel, a shortcut between two distant points. It's kind of like solving a quadratic equation and getting two answers, two solutions to the same cosmic puzzle. Let's use a simple analogy. Draw two dots on a piece of paper. The shortest path seems obvious, a straight line. But if you fold the paper and poke a hole through, you can connect them instantly. That shortcut is what a wormhole does for space. Or take our planet. On a flat world map, flying from Delhi to New York looks like a long straight line over Africa. But unfold the map into a globe and suddenly you see the fastest way is actually a curve over the North Pole. The map was lying to you. Before we go deeper, if you want to learn how AI is transforming science and storytelling, check out my AI masterclass. You'll see wild creations, art, websites, music, all built by AI. Scan the QR code to get started. Back to wormholes. The name itself was coined by physicist John Wheeler. Picture a worm, burrowing not across the surface of an apple, but through its core, creating a hidden tunnel. That's the idea, a shortcut through the folded fabric of space. Now, you've probably seen wormholes drawn as two cones joined at their tips, flat and simple. But in reality, if they exist, they'd be spheres. Grand, glowing mouths distorting the stars behind them, like a glass marble on the universe's surface. Step inside, and the view would curve and twist around you. Here's where it gets even crazier. In theory, wormholes might not just bridge space, they could connect different times. Step in, and you might find yourself not only somewhere else, but someone else. But of course, there's a catch. The same gravity that can make these shortcuts possible can just as easily turn them into deadly black holes. The forces involved are immense, enough to shred anything, even light itself. So the ultimate question, can humanity ever cross the cosmic divide? Or are wormholes destined to remain for now? A beautiful, mind-bending idea, waiting in the dark, just out of reach. Pause. Linger.